Y24 for momentum, and E equals mc squared. In Euclidean space, rotation matrix inverse was obtained very simply by taking transpose. And we remember the determinant of a rotation matrix is always +1. For example, the rotation about the z-axis keeps the z component the same, and it changes x and y components. Its determinant is trivially 1. There is another transformation in addition to the rotation that keeps the x squared invariant. That is, for example, parity. Parity is reflecting the position vector with respect to the origin by -x. If we use this transformation, its determinant is trivial, that is a -1 cubed, that is -1. So this parity is independent of rotation. Rotation generates a construct, a continuous group. This parameter is continuous, but this parity is discrete. For example, parity squared is trivial to, we can find this identity matrix. Under parity, we can distinguish vector and axial vector. For example, these are vectors. A vector rotates on the rotation in this way. In addition, x prime equals -x under parity. This is true for momentum because it is a time derivative of velocity, is a time derivative of position vector that is a vector that changes its own sign under parity. And kinetic energy, that is a square, is an invariant under rotation and parity. That is called the scalar. Even though angular momentum, that is x cross p, is transforming the same as a vector, it is not exactly the same as a vector, because if we make a transformation called the parity, x becomes a -x and p becomes a -p, and this minus sign cancels. So it is invariant on the parity. That is different from on the parity, x vector becomes a -x. So this one has a different sign on the parity. We have a special name, this kind of vector, even though it satisfies the same rotational property. Because of the parity, we call this one an axial vector. Similarly, a vector squared is a scalar. However, triple scalar product changes its sign on the parity. It is invariant on the parity because this squared is this one. However, if I flip the sign, -a cross -b dot -c equals -a cross b dot c. This kind of scalar is called pseudoscalar. Pseudoscalar. So axial vector and vector, they are the same under rotation. However, on the parity, they are different. axial vector and vector, they are different. Pseudo scalar and scalar, they are the same on the rotation. However, on the parity, they have different sign. Let us extend our method to consider a full vector. Usually, we use the italic letter to represent the Cartesian component k equals 1, 2, 3, represent the x, y, z component. However, we have additional component in full vector, especially in the space-time coordinate. We have a name for displacement. We use Greek indices that mu or nu, alpha, beta, lambda, something like that. That indices have 0, 1, 2, 3. They have 4 components. That's the reason why we attach 4. And special notation is used for the lower index that flips the sign of spatial component. That is nothing but the multiplication, effect of multiplication of a metric tensor. When we define the scalar product, we do not multiply identity matrix. Instead, we multiply this metric tensor with negative sign on the spatial component. That's the reason why we use one component has a lower index and the other one has an upper index. In this way, it is effectively transpose x0, x1, x2, x3, 1, minus 1, minus 1, minus 1, x0, x1, x2, x3, multiplication. This is effectively the same. For displacement, we take the time derivative. Unfortunately, this time is not an invariant quantity. It's a varying. It depends on v. So it's not a good idea to take the time derivative with respect to a variable time. Instead, when we construct the formula, we make use of invariant time that is called the proper time. Let us make use of the proper time. For displacement, time derivative with respect to proper time is called forward velocity. It is different from usual velocity. Usual velocity is time derivative with respect to normal time. That is gamma tau. Let's do this calculation. We know t equals gamma tau. So we have a trivial derivative. Finally, for velocity has 4 components like that. Why don't we square this 4 velocity? 4 velocity squared is zeroth component square subtracted by spatial component. This gamma v squared should be moved outside, right? Gamma v squared. So if we factor gamma c squared out, it becomes this one. We remember this one multiplied by this one is 1. Now we can see u squared is c squared, speed of light squared, so invariant quantity. Because for vector, scalar product is always invariant under Lorentz transformation, our for velocity is much better than this velocity. That does not satisfy the Lorentz transformation. Next, we construct momentum by multiplying mass. However, mass depends on the velocity, so what we multiply is not the general mass, instead the mass measured at the rest frame. That is called the rest mass. Then rest mass is just like a proper time and proper length, rest mass, everything is invariant on the Lorentz transformation. Using this, what we find for the square of the 4 momentum, square of 4 momentum, because it is m0 multiplied by u, and u squared is c squared, what we find for the p squared is nothing but m0c squared. That is invariant quantity on the Lorentz transformation. Okay. Now, 4 momentum can be written in this form, and we know p squared is m0c squared. Now, let us look into the zeroth component, meaning of the zeroth component. First of all, spatial component P is if I copy this component, gamma multiplied by m0 v. Okay, velocity is usual velocity, time derivative, not tau, but time derivative. And we have a m0 missing in here. All right, so we have a factor, gamma factor, that makes we can interpret this as the mass. In general, mass of a particle is not the same as the rest mass, but it grows up as the speed increases. And the mass of a particle can grow up to infinity as the speed of a particle v approaches the speed of light c. So this is a new definition of mass, and it is now understood if we consider the expansion. For example, we can make a binomial expansion if v, magnitude of v is less than c. We can make binomial expansion whatever x value that is whose magnitude absolute value is less than 1. If we expand this one, you will find this kind of terms. As v approaches c, you have to sum to the infinity. The explicit form, exact form is this. If v is much smaller than c, you can see the non-relativistic limit Newtonian expression for the momentum is reproduced. Now, the 4 momentum has the zeroth component, and actually in the main class, we have evaluated the kinetic energy of a particle from the rest frame to the frame where the velocity is like that. And we have identified that P0 is nothing but the energy of a particle divided by the speed of light. And what is the energy? That energy is mc squared, and that energy is m0c squared over 1 minus v squared over c squared. And what is the kinetic energy? Kinetic energy is m0c squared subtraction and m0c squared divided by this one subtracted by this. This is the kinetic energy. And when v equals exactly 0, this kinetic energy vanishes absolutely. However, even if a particle does not move at all to have no kinetic energy, it still has a kind of energy that is called the rest energy. And this rest energy m0c squared is the source of atomic power plant and atomic bomb. And because of the speed of light squared is a very, very large number, the tiny amount of mass lost results in a great amount, enormous amount of energy that was discovered by Einstein. Finally, we have for momentum squared is E over c squared subtracted by momentum squared, and that is mc squared. For a photon, we have this rest mass is 0. Why? If it is not 0, there should be a rest frame of a photon. But we have never seen a photon that is not moving. Photon is always moving with the speed of light. Therefore, the rest mass of a photon is 0. In that case, its energy and momentum, they are linearly dependent, proportional to the momentum. If a particle has the mass, non-zero mass, for example, electron, proton, something like that, its energy is expressed as the square root of momentum squared plus rest mass times the speed of light squared. As a result, as I already told you, energy of a particle is a mass times speed of light squared, and its mass depends on the speed that is represented by the Lorentz factor. These are repetition. So today we learned that energy of a particle can be expressed in terms of this, and momentum of a particle is mv. However, this m depends on the velocity, that is mv, that is x dot, and the square root 1 minus c squared x dot squared. From tomorrow, we will study the experimental verification of this crazy idea. It is a consequence, direct consequence of the fact the speed of light is invariant. And Einstein's interpretation of this energy is indeed verified by photoelectric effect and Compton effect. And especially Compton effect verify the full version of the four components of the four vector are physical. And this is not imagination, it is fact. It is verified fact through experiment.